So hello everyone. For our today's question, we have a question that reverts the nodes in a k group size of linked list. So in this question, we have given a linked list and we have to reverse the linked list up to the k node. So for example, we have a linked list from 1 to 10. So we will be reversing the linked list and returning the new head along with the reverse linked list. So if our linked list is like 1, 2, 3, 4, 5, 6, 7 and goes to 10, so we will be reversing, and if k value is 3, so we will be reversing the linked list as 3, 2, 1, 6, 5, 4, 9, 8, 7, and because k value is 3, so remaining nodes like 10 is the single node, so it will be returned as it is given. So the next linked will be 10, and that's how our linked list will be returned. So this is the question. So for solving this question, I have used a technique. I have basically divided my whole question into 3 segments, and I will be solving each of segment and connecting them and eventually solving the whole question. So our first target will be to define the kth node. Like if k is equal to 3, so our target will be to reach up to the kth node, and after reaching to the kth node, we will be separating that linked list separately and making it a small linked list so that we can reverse, as it is not possible to reverse the half of linked list. We have to reverse all over the linked list, so we have to divide it and pointing it to the null. So we will be firstly maintaining a next pointer so that we can reach to the 4, and after then we will be dividing our linked list, and up to 3 we will be, our 3 node will be pointing to the null, and after pointing to the null, it gets separated from our main linked list, and after this we will be reversing the linked list, the kth element linked list, that is 1 2 3 as 3 2 1, and after this we have two conditions, like is it is the first linked list, that is the head linked list, so we have to return the head. So we have to be set in our mind that as node 1 will be the head initially, so we have to change that head from 3. Or if the linked list is somewhere in between, like 4 5 6 is a between linked list, so we have to remember that we should connect that linked list to our previous linked list that we reversed. Like we have reversed the linked list 1 2 3 as 3 2 1. Now we will be connecting that linked list using a previous pointer to our next linked list, that will be uh, 4 5 6 as 6 5 4. So we will be connecting that linked list, and that's how we will moving forward. So there will be 3 division. First, to find the kth element. Second, to divide the linked list and reverse it. And third, the major orchestration part. So that's how we will be solving. So the steps will be including as find the kth node, get a next node, break link, and make it to the null, reverse the linked list, connect previous node to our current head or the small node, and preserve our previous node, as it is necessary to preserve the previous node, else we will be forgetting to link that with the next node, and we are not able to traverse back in linked list, so we have to make sure that we use the previous pointer to preserve it. After that, we will be, if it is head, then remember to change the head, or if it is any middle linked list, so we have to connect that with the previous linked list. So they are the major two questions. So I will be telling somehow how the pseudocode will be flow. So the flow chart of our pseudocode will be as we will be initializing the temp as head, and there our loop will be run while temp is not equals to null, and we will be initializing the kth node. We will write a separate function for the kth node element, where we will be traversing with k, decreasing the value of k, and if it reaches to the k greater than 0 or k is not equals to null, we will be stopping, and until that we will be going from one node to another node, so that we will be reaching to that length. So that's how we will be returning our kth element. Our first task completes here, and now we will be checking if the kth node is equals to null, means is it the node that is from connecting with the head. So we will discussing it after onwards. So if this condition comes, we will break, and we will be breaking our node. Then our we will make sure that next pointer points to the next node, and that's how we will make sure that before breaking the node, we can connect our node with the next link. So for that, we will make sure that next pointer points to 4 for this example. So, and our kth next will be null, and then after onwards we will use reverse function to reverse our linked list. We have discussed the reverse linked list previously, so I will be not telling about that. So we will reverse our node and then check that if is it the first node, like is it the first instance where our linked list have head and we have to change the head. If that's the case, then head will be changed with the kth node, and as our previous nodes next will be connected to the kth node, as I have told earlier why it is necessary. After this, our previous node will be as temp, and our temp will be as our next node. That's how we will move forward. Coming back to the kth node, if equals to null, so we will be checking that is our previous node's next is equals to temp or not. So for this, like I am giving the example that is if our linked list ends at 10 and k is equals to 3, so we have already reversed the linked list as 321 and 321 and 654 and 987, and now our 10 is remaining. So if that condition arises, so we have to simply add on that as it is. So for that, we will be checking if our kth node is at null, and for that we will be adding the our 10th that node as it is without reversing, without anything. So that's how we will be solving this problem, and that's the question that I have solved, and I have solved this on LeetCode as well. Coming on the complexity, so for the complexity, it will be taking big O of n for reversal of the nodes, and big O of n for coming to the kth node, for calculating the kth node in our linked list. So overall complexity reaches to big O of 2n, and we have not used any extra space, so space complexity reaches to big O of 1. That's how we will solve this question, and that's enough. And we will be targeting to complete our linked list tomorrow, so we will be solving many questions tomorrow. So maybe tomorrow video may be much longer than expected. Hope we will complete our linked list by end of this week and starting our stack and queue, and we'll be able to cover that by the end of our November. So until that, stay tuned, stay happy. Thanks.